to 0, then you have two roots. Discriminant is equal to 0, one root, and discriminant is less than 0, no real root. So let's consider this question here. Question number 1. I want to check here what is the discriminant. The discriminant here is b squared minus 4ac. Right, without the square root, you don't have to consider the square root. And for the first case, my b is equal to my a is equal to 1, and b is equal to 3, and c is equal to -half. So in this case, this one is for part 1 is b squared, so it's 3 squared minus 4 times 1 times c -half. Right, so I will have 9, and then this is minus become plus. 4 over 2 is 2. I don't really have to calculate what the number is. I mean, yes, I can calculate, but all I need to know is that it is larger or less than 0. So in this case, the discriminant is larger than 0. So you write, since the discriminant is larger than 0, there are two real roots in y equal to x squared plus 3x minus half, for example. So I can write that, right? Number 2, how many roots are there in this? So in this case, a equal to 1, b is equal to 1, and c is equal to 10. And the discriminant is b squared, so 1 squared minus 4ac. So here 1 minus 40. Well, it's minus 39, and this is less than 0. So since discriminant is less than 0, then there is no real root in y equal to x squared plus x plus 10. So that's it, right? So here is, that means my discriminant must be equal to 0, right? So let's consider b squared. So what is discriminant? Discriminant is b squared minus 4ac. And in our case, a is equal to 1, b is equal to 5, and c is equal to k. So discriminant here is 5 squared minus 4 times 1 times k. So I have 25 minus 4k. And I want 25 minus 4k to be always less than 0. That means 25 is less than 4k. And k is greater than 25 over 4. So that's my answer. If I want a y to be always larger than 0 for all x that is real number, then I need my k to be larger than 25 over 4. Image that we want is something like this. This is axis, and I want the graph to be like this. Similar to question, this is similar to question number 2 before, right? I want the graph to be like that. Again, here I want the discriminant to be less than 0. Discriminant less than 0, because there is no intersection. No intersection. So please remember, no intersection and not greater than 0. If this is greater than 0, the discriminant greater than 0, then you have two real roots. This is not what I want. I want the graph to be completely above the x-axis. So no intersection, discriminant less than 0. So what is the a in this case? A is 2, and my b is equal to 1, and c equal to c is equal to 11. How am I discriminant looking? This is b squared minus 4ac. So this is equal to 1 squared minus 4 times 2 times 11. Okay, that's great. So it's 1 minus 88. So this is definitely less than 0. Since the discriminant is less than 0, and the coefficient of x squared is 2, then the graph of y equal to 2x squared plus x plus 11 opens upward and never intersect the x-axis. So, right, y equal to 2x squared plus x plus 11 is always greater than 0 for all real number x, for example. So this is the thing. If you stop at here, delta is less than 0, that is not enough. Right? Delta, no intersection alone doesn't mean that it's like this. It could be your curve is like this as well. Right? Your curve can be like this as well if there's no intersection. Here is delta is no intersection. Right? Delta is less than 0 and delta is less than 0. Right? There are two cases, but delta is less than 0. So what I want is that I want this case and not this case. So I need to then identify that the A here, the coefficient A, must be greater than 2. That is open upward. So this is the case that I want and not this case. So you must complete this by saying that and the coefficient of x squared is 2. Then the graph opens upward like this and not this case. So we need to root out this case. So this is method number 1. Right? There is another method of doing this problem without using the discriminant. Right? That is using completing the square. So this is method number 2, completing the square. And this, to do it this way, y equal to 2, right? Factor out the 2, so x squared plus x over 2 bracket plus 11. And then 2, right, x plus this number divided by 2, so divided by 4, sorry, 1 over 4, everything squared minus 1 over 4 quantities, everything squared again, plus 11. So completing the square. So x plus half of this coefficient, so 1/4. So then you have this minus 2 times 1 over 16 plus 11. So this is 1 over 8 plus 11. So it's plus 10, 7 over 8. And you can see that here, the minimum value here is 10. This is the minimum value, 10 plus 7 over 8. This is called always global minimum. This global minimum is always going to be larger than 0. Therefore, I've then shown that this function is always larger than 0. In fact, the global minimum is which is larger than 0 for all x is a real number.